Good afternoon. Today we'll be completing the last beat which is remaining in the first unit, and today we'll be discussing upon a concept of saturation system, or it is also known as maximum utility system. And this method is used to determine the optimum road length or to find out various alternative. Now generally you have a numerical based on this topic, but keeping aside that numerical part and the exam part that we'll be covering soon. But before that, I would like to start this topic with the uh, different way, in the sense the numericals are quite simple, you can solve it, and I'll be explaining the same. But why we need to actually go for this method, that will be seen first. So consider first scenario. Now this picture is familiar to you. This is of the Sirmoor bypass that we have been discussing for the past week in the alignment lecture. So consider the scenario one, that we have to select alternatives for a bypass of a town or a city. So this is the town that we were looking, Sirmoor, and we had four options. So now if I have to select alternatives, one of the alternatives from these four, so which one to select? This is the first scenario and the first question. The second scenario is, now again this is from the same project that we have been discussing, the Satna Shankargarh project from MP-UP border. So after this Sirmoor, if you can follow the arrow that I am just pointing, the white arrow. So after this point, the ghat section it starts, the road starts to descend the cliff, and that is the Barda Ghat. And once the ghat ends, I have marked the point, end of Barda Ghat. So then we have to go towards this village called Java. So to go to this village, we have two alternatives in that project. So either you can go by this blue alignment, which is 15.7 kilometer, or by this red alignment, which is 19.6. So that is another decision to make in this scenario, that selecting alternatives for alignments joining two locations. Now this is one typical case that I have shown here. The similar cases can be found out for any project if you are working as a highway engineer, whether on site or in the design office. So many a times there is a question that you can go to from A to B by two or more possible ways. So which one we should select as a project road? So that is the second question and the second scenario. Now for the third scenario, what I have done is, there is something called phasing of road program. Now for this is the scenario that I have developed. Now if you look at this picture, so it's an area under the jurisdiction of PCMC, Pimpri-Chinchwad Municipal Corporation, and I have highlighted four roads. Now the first one, the yellow one, so it's from Mukai Chowk to Nigdi Bhakti Shakti. So it's a 5.29 kilometer stretch. It's the new road which is under construction. You all must have seen at some point of time, which crosses the railway line near our college, near the Sunset Point. So this is that road. The second road is from Bhakti Shakti itself to Talode. It's the spine road. The ones who live in Chakan Moshi area, they might be knowing this. So it starts from Bhakti Shakti and it goes towards the Talode junction. So it's a 4.68 kilometer road. The third road is road connecting Dehu to Alandi. It's a 15 kilometer stretch, the one showed in orange. And the fourth one is the pink one, which I have shown. It's joins Talegaon to Chakan area. It's a 22.8 kilometer stretch. Now, what is in this scenario 3 is PCMC has a decision to make, that they have these four roads which need to be improved or which needs to be constructed. You can consider any one. Now, in the actual case, if you know the roads, this yellow one, Mukai Chowk to Nigdi, it is under construction, and the rest of the roads, they are already there. So might be PCMC might have a proposal that these four roads have to be developed. We consider that scenario. But they have a constraint on the budget. that they cannot develop all the four roads one at a time, or all the four at a time. They need to phase it. Phase it as in they need to decide which road they will construct first. Then after how many years the second road will be taken up for construction, then the third, then the fourth. So that is the phasing of the road program. Okay, so this is also a typical actual scenario which comes into picture in many of the road projects, that certain government agency, they have many road or a huge road network in their area, and somehow there are, suppose out of n number of roads, uh, x number of roads are there which need upgradation, but they have a constraint on the budget side, so they can't upgrade all the four roads, all the x roads at a time. So they need to come up with a phasing program. Now, why I showed you these three scenarios, the answer or the method, one of the method that can be implemented for answering all the three questions in these three scenarios. That is, the first question in the first scenario was which alternative to select. The second question in the second scenario was which alternative to select from the two to connect point A to point B, in this case the end of Bardha Ghat to Jawar. And the third question for the third scenario, it was out of these four roads, PCMC has to decide which road to undertake first, or construct first, or upgrade first, or develop first. So these are the three questions. Now, the answer to these three questions, you can also give from your understanding. Obviously, I'm not expecting that you must have analyzed all that and you'll be giving answer. So suppose for scenario one, so we have discussed this in detail, so I'll not expect the answer for this. For scenario two and scenario three, just look at the roads. So for scenario two, if you see, there are two alignments. One is 19.6 and one is 15.7. We can call it the blue alignment and red alignment. So what do you think, which alignment should be selected? Just type your answers in the chat box. This session will be or it will be conducted in this way itself, that I'll be asking questions and then you will be answering, and then at the end, in the last 15-20 minutes, we can go for the numerical. But it's important to understand the concept of this maximum utility system. So for that, just answer this question now, that in scenario 2, out of the red alignment and blue alignment, which one will you prefer? If you are given the task of finalizing the alignment, you are the project manager or the design head in your company with who is leading the team, and suppose you have to take the decision. So which alignment you will see, or which alignment you will select, the red one or the blue one? Type your comments in the chat box fast. Okay, there are three answers till now. Others can also answer. Three of them are saying that the red one. Okay, four for red, red. Okay, I would be much happy to see a little bit more participation. Anyways, the number is less today. There are only 24 students. Red. Okay, so quite a few answers that I have received. So whatever I have received, everyone is saying it's red. Okay, so you might have selected the red alignment on some parameter. So what was that parameter? Now answer that. Whoever has answered the red alignment, what was the parameter that you selected? Or why red alignment? I'll repeat my question. Most of you have selected the red alignment, which was 19.6 kilometer long, over the blue alignment, which was 15.7 kilometer long. So why this decision was taken to go for the red alignment? Okay, so the answers are: it connects more towns, more connectivity, joining more villages. Okay, so from this figure, I don't think you might be able to guess the number of villages, but if I just open this picture in the Google Earth Pro, and if I zoom over the alignment, you would be surprised to know that there are more number of villages on this blue alignment, and there are very less number of villages on this red alignment. The length is more for the red alignment, and the length is less for blue one. So one of the or most of the answer you are saying that joining or connectivity. So that's not the case in red one. Kiran is saying feasibility and future scope. Okay, for future scope and feasibility, the second, the red option is more suitable. Future scope, as in, as I told you, this blue one is going through more number of villages. So this is a rural road. So if any one of you have seen rural roads, so generally near the roadside, people tend to have the settlement. Yes, or the road. It's not a national highway yet, or it was not a national highway till the point we were doing this project. So it was not a national highway, so the road was not, or the villagers were not actually thinking that it's a national highway passing through our village. So most of the villages were somewhere like this, half a village on one side of the road, half the village on the other side of the road. So like that. So if we go for the red one in that case, so it has less number of villages. So in future, if we designate it as a national highway and go for widening and so in that case, this would be more feasible from that perspective. Okay, so Kiran's answer is right in that sense that feasibility and scope. That is the reason that you could go for the red alignment. Okay. Now coming to the third. Now in this, let me know that out of these four road programs or the roads that you are supposed to deliver, suppose you are the executive engineer in PCMC, and again, the decision is up to you. You have to decide that amongst these four roads, which road you will be giving priority for development, or which road you will be constructing first or upgrading first. So if you are given the decision to make, what will be your decision? Which will be the first? You can just write your priorities like pink, orange, green, yellow. So I hope the colors are distinguishable. So pink one is the Talegaon Chakan road, orange one is the Dehu Alandi road, green is the Nigri Talode road, Spine road, and yellow is the Mukai Chowk to Nigri road. So among these four, if you are told to come up with the phasing program or come up with the priority, which four you'll or what will be the priority that you will be giving, what will be the sequence? Okay, so for Chakan Talegaon, I have got three answers for the pink alignment. Is say they are saying that that will be the first. Okay. Only three answers till now. Again, I would like to see some more answers so that I will come to know what in which way you are thinking, or are you thinking in the right way. So again, I'll repeat my question: which are the three alignments, or which are the what is the sequence of the four alignments that you'll be putting in the phasing program? That is, which will be the first, second, third, fourth. So till now, the three answers that you had given, so it was all written pink. Okay, so that is the first, but I would like to know the sequence. So you can write in the same sentence itself, pink dash green dash whatever it is, whatever is the sequence you think is best suited. Okay, so Kaustubh had told the pink one because his it connects to MIDCs. Okay. Taskar is saying pink, orange, green, yellow. Okay, so the first is Talegaon for her, then Dehualandi, then green, then yellow. Okay, so pink, orange, green, yellow again. Okay, I hope you are not copy pasting pink, orange, green, yellow. Yeah, but okay, most of you, whatever sequence you are telling, the first road that you are telling is the pink road, okay, or the pink alignment is the priority one that you are connecting now. Amongst the answers given, only Kaustubh has told the reason. So now my next question is, what is the reason that most of you have selected the pink alignment as the first road that you will develop? Any specific reason? Kaustubh has given his that it connects to MIDCs. So that is okay. That can be considered as a valid uh, point for discussion. Others, what is your reason that you have selected that pink alignment as the first one to develop or first one to construct? Okay, those have given answers. I expect that now you give the reasons why pink was the first option for you. Sumit, Madhubala, Tushar, Rutuja, Swapnil, Hire. Okay, so Taskar is saying it has many road connections. Connectivity against Kiran is saying connectivity. Okay, so you decided connectivity on just the basis. Now, purposefully, what I had done was I have switched off all the existing road markings. If I switch on again, if I switch on the existing road markings, uh, the answer that you're saying that connectivity. So most of the roads are concentrated in this area or the area which I am circling by, or the area around orange, green, and yellow alignments. And those of you know who know this alignment, Talegaon to Sakan. So Talegaon, it's near the expressway, and in between you don't have anything in this area, or you just have villages, and then you have Sakan MIDC here, and then you have Sakan. So likewise, if you see, the only main thing is the industrial area. Okay. So now, those who have answered, I believe that some thought process has started in your mind. So these are the decisions that you need to take actually when you work as a highway engineer. So now to take these decisions, one of the tools that can be useful is this saturation system or the maximum utility system that we'll be seeing now. So now my whole purpose of asking those or giving these three scenarios and asking you three questions was that uh, to think or to start the thought process, and in that thought process, whatever you have uh, given the points of connectivity or the MIDC area or which alignment to go the first. So all these points, they were based on whatever knowledge you have gained so far in the first unit, and also it might be from your experience of traveling on one of those roads and your common sense. So in more technical way, when we as an engineer, we need to select any alternative from n number of alternatives. So we just can't say it that it is based on our common sense or our logical thinking or your gut feeling. So it has to be backed with some logical reasoning and some explanation, and mainly the calculations. So that's where this can be one of the method. Now I am stressing on this is one of the method for selecting the or making the decision. There are other methods as well, but for now we'll be covering only this. So what is this method is or why it is used? It is used to compare alternate proposals and select anyone. That's the same that I've shown in scenarios. And basically it was developed in US. So in their highway planning system, they had came up with the concept of saturation system. And what is done is optimum road length or priority. There can be any one of two decisions that either you have to come up with the road length that you will be developing, or you have to come up with the priority as we saw in scenario 3. So you have to come up with the priority of proposal in calculating it, and then that is based on the concept of maximum utility per unit length. Now, this is important term to highlight that its maximum utility per unit length. Now, there are some factors considered for obtaining the utility per unit length, whatever this underlined portion I was highlighting. So to come up with the utility per unit length, there are some factors. Now, again, there's a question for you. What could be the factors that will affect, or it will directly be related to this utility per length? You can understand the, or you might be knowing the word utility. Utility is nothing but how useful is that road, okay, in terms of highway planning if we consider. So utility is nothing but how useful that road is to the users. So it depends on some factors, that utility. So I would like to know what are the factors. For hint purpose, I will let you know that there are only two factors. Okay, so there are two factors which are affecting this value of utility per unit length, and I would like to know from you what are the two factors. You can write in the chat box. What two factors do you think might affect the utility? That how useful is your road to the users. So users, if you prepare a road and then you give it, open it to the users, so your users will accept it or not. So they decide it on some parameters. So what is it? Okay, so there are a few answers. Two of them are saying population, one of them is saying industrial prosperity and agricultural progress. Okay, I hope you are giving this answer out of curiosity and understanding and not from the classes that you have attended previously for GATE or IS, even though if you have attended, it's good. So the first factor which is considered is the population served by that road network. So whatever road or the proposals I'm putting forward, so how much population it is serving. So that is my first factor considered. And the second factor considered is productivity. Now this productivity, mainly it is divided into two types, the agricultural productivity and the industrial one. Now, as we all know, India it is mostly dependent on the agriculture. So if your road is going through more agricultural lands or connecting villages which have agriculture as their dominant occupation, so obviously if that road is sufficing, or it is, what you can say, it is helpful to this agricultural products in any sense, that right from the sowing period to the harvesting period and taking it to the market, if in all these phases your road network is useful, so that will come under, or that will be highlighting the agricultural productivity. And same for the industrial one, that if your road is allowing the users to connect to different industries in that area, nearby area, so that was our factors to be considered. So mainly there are two factors, population and productivity. Okay. Now coming to the utility part, what is actually utility? It is a value, or more rightly, it's a weightage kind of thing, which is assigned to the road. So utility it is assigned to the road mainly, and before road it is assigned to the factors. So it is assigned based on what is the population range and how many number of villages or towns are in that population range. We'll see this in detail when we solve the numerical. And the second, it depends on the agricultural productivity, the weightage value, and the industrial productivity. So these are the same factors that we had considered in the previous slide. So two factors, and then depending on these factors, the utility value is decided. And now this weightage, now who gives this utility value or who gives this weightage? So weightage is decided by a person with sound judgment skills and experience. So now if some of you might be having or studying the TQM and MIS subject, the second elective. So if you are understanding that subject very well, so in that also you might be very well with this criteria that many of times that quality in a system is inherent because you have some people in the system who have very good judgment skills and who have a vast experience. So similar ways in highways also there are people who have been there in the industry for past 2 decades or 3 decades. So based on their judgment and experience and their research, obviously, so the weightage is decided. So coming to the numerical, we'll see how the actual proposal or the phrasing is done. So I had given this numerical yesterday or shared this numerical with you yesterday. So I hope you have seen it and written the question. What is there in this numerical is an imaginary area has existing road network. Now for just numerical purpose or academic purpose, it's an imaginary area considered, but you can very well apply it to the actual projects also in the actual field. So that in the road network, it has alternate proposals. Okay, there are 4 proposals: P, Q, R, and S with different road lengths. So you can consider this scenario as the third, or this numerical you can relate it to the third scenario that I had shown a few slides back, that you had 4 different roads and that 4 different roads had different lengths. So they were varying from 5 kilometer to 20 kilometers in the scenario 3. So somewhat same you can see here. And what they have given is for each proposal, they have given the road length. Now, obviously, this is a bit higher side than what we saw in scenario 3, but you can relate it. And the data that they have given is number of towns and villages served with the population range. Now, as I told you, they have divided the population in ranges and they have come up with number of towns and villages. As in, if you consider proposal P, so in proposal P, there are 160 villages and towns which are having the population 1000 to 2000. 80 villages and towns which are having 2000 to 5000 population. 30 with 5000 to 10,000 and 6 villages with more than 10,000 population. So this is for proposal P. So from wherever my alignment is going for proposal P, so it is going through all these villages and those villages or towns, they are having this population range. And then as we have seen, your utility of the road, it is mainly concerned with the agricultural and industrial product. So here they have given that total product. So this is in 200. For here, this numerical, they have not given the unit. So you can assume, no need to assume any unit as well. But what they have given is 200. The values are in thousands. Thousands as in, this 200 is nothing but 200,000. So whatever are the 1000 terms, so three zeros, they have just took it common and they have just written in the column heading. So that 1000 means this value. So this 200 is nothing but actually 2 lakh units, you can say. This is 2,07,000 units. This is 3,15,000 units and so on. So this is the data and this is given for each proposal PQRS. And at the end, they have given the utility units. Okay. So this utility unit is nothing but the this weightage or the value that we were discussing in the last slide. So this is those values or weightage. So you can see based on the classification of the or grouping of the population, they have given different utility units. So one thing again you can stress or just see that as the population increases, the utility value increases. Now this you can very well correlate that if your villages or town is having more population, so obviously more people will be using that road that you are trying to develop. So obviously the weightage for that population group or those villages will be more. So that's why you can see for villages greater than 10,000 population, you have a higher utility value. But it's not always directly or only related to the population count. It is also related to the number of villages. So if suppose there are 160 villages with 1000 population and 1000 or 6 villages with more than 60,000. So now here only the range is given. So might be not all the villages or all the 6 villages in this number will be having exactly 10,000 or 11,000. It might be more than 50,000 also. So depending on that also these utility values are decided. So for now these are given to you. So let's proceed with this. So I just summarized the steps that are needed to solve this numerical. So first step is the utility units. You need to check whether they are given. If they are given, okay. If they are not given, you have to assume it. And the second thing that you have to check is the units of productivity, as in the productivity is given in tons or in hundreds of tons or in thousands of tons, like in the question that we are dealing with. So there is no unit of tons or kg, but they are given that utility or the productivity, it is in thousands. So we'll see the first two steps. So in the solution, this is the numerical given. So the first step is to check the utility, whether it is given or not. So for population, it is given. The utility values units are given, so it's okay. But for productivity, there is a dash, so you need to find the utility. Now we can't find, we'll assume it. So assume it as 1 for this numerical purpose. Coming to the third step, in the third and fourth step, what you have to do is you have to multiply the utility units of population with respective number of villages or towns segregated with respect to population ranges, as well as multiply the utility units of productivity with respective productivity values. And check, you have to check for uniformity. Now what I mean by this is, again, I have just taken the same table in the question, and I'll be doing the calculation. Now what is the meaning of step number 3 and 4 is uh, the step number 3 and 4 that take the utility units and multiply it with the respective values, that this utility 0.25 for this population range of 1000 to 2000. So you have to multiply it to the respective number of villages or towns for each proposal. Okay. Similarly, this 0.5 utility, it is for 2000 to 5000 population range, and you have to multiply it with the number of towns and villages for all the proposals. Similarly, for 5000 to 1000, the range is or the utility is 1, so multiply it to all the values. For greater than 10,000, it's 2.5, so multiply it to all the values of number of villages and towns. And similarly, for productivity, now we have assumed 1, so we assume that utility unit, it is 1 for every 1000. So the values in this column are also in thousands. So likewise, you have to just multiply it by 1. Okay. So that's the third and fourth step, that you have to multiply the utility values with the respective number of towns and villages and the productivity as per the proposals. I hope that's clear. Now in the fifth step, fifth, sixth and seventh, if you see, fifth is you have to add values from step 3 and 4. So whatever values you have multiplied, you have to add them and you have to find out total utility. Then you have to divide that total utility by the road length, and then you have to find out the total utility for each road or proposal. So again, it's the same table, I have just modified it a bit. So this is the multiplication that you will be doing. So for first step or for proposal P, you have multiplied all these values: 160 by 0.25, 80 by 0.5, 30 by 1, and 6 by 2.5, and 200 by 1. So you have to just multiply it. This will be the values that you will be getting: 40, 40, 30, 15, and 200. You have to add it up and you have to come up with the total utility. So that comes out to be 325. Similarly, for proposal Q, whatever is the multiplication, you have to do it. These are the values that you get: 50, 45, 60, 20, 270. You have to add them up. It comes up to be 445. Similarly for R and S, the same thing. And these are the total utility values. Now the next step is you have to divide this total utility by the total road length for respective proposal. As in for proposal number or for proposal P, the total utility is 325. So divided by 300, you will be getting what is the maximum utility per kilometer. So it comes out to be 1.08. So in the same way, for proposal Q, I'll be dividing or 445 divided by 400. For R, 525 divided by 500. For S, 556 divided by 550. So I'll get some ratio. So as you can see for proposal P, its maximum utility per kilometer, it is coming out to be 1.083. For Q, 1.112. For R, 1.05. S, 1.01. Now what do you mean by this term maximum utility per kilometer? That you get a comparison that for each kilometer of the road built in that proposal, how much will be the utility of that road from user point of view. So obviously if I have to compare, so that maximum utility per kilometer is greater, or the maximum for proposal Q, as you can see, it's 1.112. Then you have proposal P, then R, and the least utilities for S. So now once we get this, now we are in a position to firmly make a statement that, okay, if suppose I have to take a call that which road I will develop first, so the priority will be such that proposal Q, it will be the first priority, proposal P second, proposal R third, and proposal S fourth. Now from where this priority came, it came in the sequence of the maximum utility per kilometer for the proposal. So the proposal or the road which has the maximum utility per kilometer as the maximum value, so that goes as the first in the priority, and then likewise the order follows. So it's a very simple numerical. It's very easy. Now just the thing you have to consider or you have to keep in mind is the units. Now what I mean by that is, if you see the second numerical, so this you will be doing it as a homework. So for this, you have three roads A, B, C. The length is given. A, B, C, the length is given. They have given the population ranges. Again, they have given number of villages in each of the population range. Now, productivity, they have given in, and now they have separated agricultural different and industrial different. And they have given in 1,000 tons. Now, that means this 15 is nothing but 15,000 tons, actually, okay? This 11 is nothing but 11,000 tons. This 20 is nothing but 20,000 tons. So that's the meaning of this in 1,000 tons. Okay. Then for industrial, it's 1.2. Again, it is in 1,000 ton. That is, if I multiply 1.2 into 1,000, so whatever is the answer, that is the actual industrial productivity that you have. Okay, so it's 1,200 ton. Okay. Here it's 0, so it's 0 ton. Here it will be 800 into 1,000. 0.8 into 1,000 is 800. Okay. So that's the value. Now utility units, if you see, so some locations they have given the values, as in here they have given 1, but for other population ranges you have to assume. Now remember, when you are assuming, you have to assume it logically, as in, as I told you in the last numerical, the population plays an important role. So if you are connecting more population, or you have having villages with more population, so that will have more impact on your road and the decision that you have to make. So obviously the value of this utility that you will be assumed, it will be greater than 1. and the value of utility that you will assume for this category less than 2000, it will be less than 1. So that's why they have given the center value and they have left up to you to assume these values, but this should be logical. You should not assume this value as 2 and this value is 1.5 or something like that. So it should be logical. That's why you should follow this system. Okay. And for productivity in agriculture and industrial, now you can see what they have given is productivity or the utility unit for agriculture productivity, it is 1 for 1000 tons. Okay, so for 1 for 1000 ton, it's no issue. You have to just multiply. Just erase this so that, okay. So these values are already in thousands ton. Okay. So what you have to do is you have to just multiply it by 1 straight away and you will be getting the utility. And then for industrial, now here there is a change. Industrial, the utility they have given is 1 for 100 tons. But what we have utility values here, also productivity values here, those are in 1000 tons. So either we need to change the utility unit or you have to change the productivity. So what I'm saying is, suppose you are deciding to keep it 1.2 as it is. So here then you have to multiply this by 10 so that your utility becomes 10. So that 10 will be for 10,000 tons. Okay. And then you can multiply this 1.2 with 10. Okay. And if you don't want to change this utility unit, if you have to keep it 1, so then you have to divide this value, this 1.2 by 10, so that both the things are in hundreds. Okay. So that's what I meant by the step that you have to, when I said this statement, that you have to check for uniformity of units. Okay. So that is the trick that can, or the confusing part that you can face in the exams. So they can change the units, and then if you are careless about it, you will just go on multiplying and adding, and in that case you will be ending up with the wrong sequence of proposal. So keep in mind, this is the catch that you can, or the variation that you can have in the question. So I hope this is clear. The utility concept is clear. Rather than the numerical, I am more concerned about the concept. So if your concept is clear, then the numerical is just a mathematical calculation of addition, subtraction, and division and multiplication. Okay. So this was it. So here we finish with the first unit. Okay, we have completed all the bits and a few topics I have given for self-study, and one more topic for self-study is the Road Development Plan Vision 2021 and Rural Road Development Plan Vision 2025. I'll be sharing the PDFs of these two plans, which you can also get it from the government websites. But anyways, I'll be sharing these PDFs with you in the Google Classroom, and then you can very well just study this topic. So this is the end of the first unit.